Hey everyone, welcome. Today we have a special edition of an AppScript talk for you. We're going to be talking about the chart service. But before we get to that, I'd like to introduce a new member of our developer relations team for AppScript. This is Dan Lazen, and I'll let him introduce himself. You've been working here for how long, Dan?
Oh, all of 3, maybe 4 weeks now.
All right.
Pretty much an expert now. I'm a new tech writer on the developer relations team for AppScript. I'm going to be helping to improve some of the documentation and make sure that you guys can find the information you need to know.
All right. It's great to have someone newer than I am. Finally understanding how to get things done. All right. Let's start. So today, I'd like to talk about how you can use the chart service in AppScript in order to do really quick dashboards. You can integrate it very easily using the capabilities of AppScript that you might have already gleaned from other tutorials or other videos. One example of such a thing is easy interaction to spreadsheets. Any data that you have in spreadsheets, you can just pull in really quickly, throw up a dashboard, and everyone can have controls and filters on it, interact with it, drill down, visualize the data any way they want. It's also easy to get the data from external sources, and I'll cover that. So I'd like to start by going through a couple of slides. Let's see. All right. Everyone can see that? Great. All right, so basically, what is it? We're going to be creating a dashboard, which is a combination of several things. We're using a data source to get some data into our AppScript application. We're going to add charts and controls to it in order to let users change the data that's visualized. And then we're going to build a dashboard in a UI app and return that so that people can visualize it on a web page or embed it in a spreadsheet or a Google site or what have you. The second part of this, I'll be doing a demo showing this interaction between a spreadsheet attached to a form and how those populated values can propagate onto a live dashboard. And then also I'll be showing you something that I built recently that I actually use in my day-to-day work. It's like a Stack Overflow monitoring system. And it's a way to query an external API very quickly using a URL fetch in AppScript and then just pull that together into a dashboard. All right, so let's get started.
Let's.
All right. So what is a chart service? It's a part of AppScript. It's a service that gives you access to several different types of charts. Examples are area charts, line charts, scatter, pie. There's many of them. Combined with controls that I'll get to later, served from a UI app. And I think I already mentioned this. So an example of how to invoke it is from a script file. You would just do var chart equals charts.new bar chart dot set data table data. So the new bar chart will give you a new chart builder. In this example, a bar chart. And then also you can add some data to it. So that's a very quick outline of how to do it, and I'll go into more detail. One of the major things that's important about the chart service is the builder pattern. It's used everywhere. So the goal of the builder pattern is to abstract the steps of object creation so that you can do it in different orders, and you can just okay, so maybe it's best demonstrated by an example. Here I'm using charts.new line chart, and that returns our line chart builder object. And on that object, I can call these various methods like set dimension, set title, use log scale. I can call them in various orders as well. And there are many more options. You choose which options you want to set and change from the defaults, and you create your chart that way. And the key to everything built this way is the build call at the end. After you're satisfied with the way you've configured your object, you call builder.build, and it returns you the chart object. So on the one side, it's a line chart builder. You call build, it returns a line chart, and then you can embed this as a chart in anything.
Nice, simple.
Yeah. All right. So one of the key things about charts is a data source. Obviously, if you're going to be showing data, you need the data to come in from somewhere. There's a couple ways to do this. A simple way, if you just want to play around and start experimenting, is to manually add the data. So you can just create a new data table builder, and then you can add a column to it for each category that you want in your chart, and then you can add a row for each entry, and then you can do build, create the data table, and then you can add that to a chart. Another way is a little bit more automated. If you have a spreadsheet with the data you're interested in, you can call you can access the range of that spreadsheet just by open the spreadsheet with an ID. As you'll see later, this is the first demo.
Using the spreadsheet service.
Using the spreadsheet service, you pull the spreadsheet really quickly, and then you get the range of the data from the spreadsheet service. Then you can just pass that directly into the data table, and it automatically populates the columns with the correct headers and the rows.
That makes it really powerful, because then you can share that spreadsheet with other people in your organization. Exactly. Everybody can be collaborating on the same data set, and you see it sort of reflected in your live web dashboard.
Exactly. And also, that's a good point that you made, that it is a live dashboard. Every time someone new goes to the page, every time you refresh the page, it'll dynamically pull the new values from the spreadsheet and then update the chart.
Cool.
And the third way is from a URL. You can actually provide a data source URL and access the data that way. I'm not going to be showing you an example of this, but I will be using URL fetch app to get some data from an external API and packaging it up into a data table object and using that in a chart. We'll get to that. It's cool. All right, so the second major part of the chart service is our controls. Controls are basically user interface widgets that can interact with a person. Like, a person can use the controls to filter the data that the data table shows. So for example, one thing would be a category picker, or maybe a range slider, or if your chart has many different people's names, you can have a text box that's a string filter, right? You type in a person's name, and it filters the chart and shows only the names that match that filter. And those are the three main types of controls: category controls, number range controls, and string filter controls. And an example of initializing those would be using the same builder pattern that I talked about before, where you just do chars.new number range filter to get a number range filter builder, for example. And then you do set filter column label. So you'll notice that this method is different from the methods for the other line chart builder that we saw earlier. And so that's an example of the builder pattern. Okay, so you can filter this on a column labeled age. Okay, and then when you call build, you get a new builder. You can combine that with the chart, as we'll see in just a second. Now, dashboards. Dashboards are a way to bring all these things together. You have your data source, you have your charts, you have your controls. How do you present it all to the user? A dashboard allows you to combine several charts into one organized layout and have the controls connect to the charts, so that as you adjust the controls, as the user adjusts the controls, it dynamically queries the data source, pushes that data source through the charts to display only the relevant data.
That's a really nice way to visualize data. Allows you to sort of on the fly kind of figure out, allows different users to sort of filter things the way they would in a spreadsheet, but doing it live right on the visualized data.
Exactly. So that's the key thing about this, right? A dashboard is not static. You don't just make a view that's like one size fit all for everyone and then publish that, and no one has any option on how to change that.
Right.
It's a very dynamic thing, and people can consume the data any way that makes sense to them. All right, let's continue to the live demos now. Okay, first demo we're going to go through is, in the interest of saving time, I've created a simple Google form. So it's very easy to create the form. All you do is you go to Drive and you say New Form, and then you can set it up. Here I have 4 questions. What's your name, your age, how do you get to work, and how long is the commute? It's a simple form to ask people, what their daily schedule is like,
right.
and then to collate that data and present it in an interesting way. Cool. Maybe. It's an example. Anyway, so I've already been filling in some data here in order to make it not too boring. But here, let's go ahead and fill in some more. I'm going to add myself. I walk to work. How long is my commute? Maybe 12 minutes. Go ahead and submit that. And as you know, Google Forms and Spreadsheets have a very tight integration where the entry that I just added gets appended.
Right.
And we can add you too, Dan. Dan.
I'm 33. I think I'm 33. I have no idea.
You're 33. That works.
Google.
All right, let's see. How do you get to work?
Data. I bicycle. I think you're going to need a new. You're going to put me down as other man.
All right, fine.
But it's New York City. It's
let's see.
About 20 minutes if I'm going fast. 30 if I'm.
You bike every day, huh?
Almost every day.
Whew. All right. Let's go ahead and submit you, and let's just add another one. Let's see, Marty McFly.
Yeah, Marty McFly.
18, I guess he was in the movies.
Always, perpetually.
Of course, he drives himself in the DeLorean.
Yeah.
And I think he can get there really quickly because he can set the time, right?
I mean, that's a negative value.
So let's say, no, I don't know if we want to get into the paradoxes of him getting there before he actually left.
All right,
So let's just say 1 minute. Keep it simple. All right. That's good enough. So we have all these values automatically populated in a spreadsheet, and this can work for any form in any spreadsheet that you might have in your own organization or among a group of friends. Now let's create a new script that will call into the spreadsheet to get the data and present it in a nice layout for people to use. So to do that, I'm going to create a standalone script going to the script.google.com. All right, let's give it a name. Let's say form visualization.
That is an excellent name.
It's very unique. I thought a lot about it. Okay, the first thing you want to do is you want to change this to a do-get. Because this is a visual representation of the data, we're going to be returning it as a web service, UI app web service, so that people can see it in their web browser. Mm-hmm. All right, now let's get started adding stuff to this, okay? The first thing that we need is we need to reference a spreadsheet. So var ss equals spreadsheet app dot get sheet by ID, open by ID. Mm-hmm. Autocomplete is perfect for that. And then to get the ID of a spreadsheet, it is this value right here. So key equals before you get to the numbered GID stuff. Just paste that in here. Okay, now when the script runs, you'll have access to the sheet. Var data is ss.getDataRange. And bam, in two steps, what you were able to do is open a spreadsheet, integrate it very tightly, and then get all the data from it.
Cool. Sorry for those who are just joining us now. We had some technical difficulties with getting the feed up, but we are now live at Google Developers Live. You'll be able to catch the first few minutes of the talk that you missed. You'll be able to catch them again earlier if you go to the saved feed of the GDL, which we'll send out a link to with our Google Developers Twitter feed later on.
Yep. And if you missed the exciting introduction earlier, this is Dan. He's a new tech writer for the Deverell team, and you can go read about his exciting biography by watching this video again.
That's going to be a great afternoon for everybody.
All right. So let's see here. What do we want to do? So if we go back to the building charts, you can step through the workflow in this way. First, you make the controls, then you make the chart, and then you add them to the dashboard, and then you present it externally. In the interest of not messing up too much on live, I do have another version of this script, and I'll be copying it line by line, but still explaining to you every step of the way. So this is what we've done so far, and the next is what we want to set up are the filters. So here we go. Now what I've done is I've set up 3 filters. If you look at our data in the spreadsheet, the columns are name, age, where do you work, and how long is the commute. So this age filter allows me to restrict the values that appear in a chart by the age column. And how I do that is I create a new number range filter, which gives me the builder. And on it, I set it to filter column index 4. And if you look at a spreadsheet, it's 0, 1, 2, 3, 4. Maybe that's wrong. We'll get to that in just a second, but there's a great debugging tool for this purpose as well. Go ahead and build that age filter. Let me zoom in there so people can see it. All right, now transport filter. This is for, obviously, if you want to drill down by the transport. But the key thing to notice, the difference between these two is that the age filter is a number range filter.
Right.
But the transport filter is a category filter. That's because when we set up the form, I set up the fields such that the age filter was a text box and you just entered your age, whereas the transport filter had options. So
Gotcha.
you could. That's why you had to choose other for a bicycle. That's why I chose walking. Anyway, there's a set number of options, and you'll see that propagate to the UI later. Now, the last filter is a number range filter. Say you have tons of data in your charts, and you want to just look at the people whose names start with K. Right? So you can create a new string filter, and then set it to filter on any text string. And once you build that, you'll see the control that allows you to do just that. All right, let's see. OK, the next thing that we want to do is add in our charts. Now, for this example, I think it would be pretty cool if we can display in a table chart what our data is. And table charts are great because they're quick. You can just say, here's my data source, put it in a table, and then it gives you the categories for all the headers, and you can say, arrange this ascending, descending.
Yep.
It's a really quick way to visualize the data.
Nice.
And a pie chart, because it's just a cool visualization.
Yeah, of course. Classic.
Right. Now, notice how I'm building this table chart here. Charts, a new table chart. That gives me the table chart builder. Then I said the data view definition. Now, when I was talking about the data tables earlier, data tables are the data that you provide to the charts. Data views are different in that they're a specific subset of the data table. So say you only want to have two columns of the data table, the first and the third column. You can have the data view represent that subset of the data table by setting up a new data view by using charts.newDataView definition and setting the columns on that. Here what I'm doing is I'm setting the data view to have columns 1, 2, 3, and 4. Now if you go to the spreadsheet, you'll see that corresponds to 1, 2, 3, and 4, all of the form data.
Right.
And I excluded timestamp.
Indexed from 0, so we're looking at everything except the first column.
Exactly.
Yep.
Because no one wants an ugly timestamp in their charts.
Yep.
OK. Now to set up the pie chart, you do something similar, except instead of new table chart here, you call new pie chart. And when you set up the data view, I set it up using columns 1 and 4. So what will that give us? That'll be their name against how long their commute is.
Yep.
So you can visualize who's spending most of the time getting to work and not working.
Nice and easy.
OK. Now the next part is setting up the dashboard. Now, like I mentioned earlier, a dashboard is a way to tie these filters and these charts together. It's a way to present everything in one logical chunk so that changing these controls will change what's displayed on all of the charts.
Right, so instead of sort of drilling down into each of the different charts, you can sort of give your settings once
Exactly.
and allow it to be reflected in multiple charts.
Exactly. So here I create a new dashboard panel, which as you notice is under the chart service. It's not in the UI service, but it is a panel that you can add to the UI service, as you'll see in just a second. When you call set data table on it, you can add data here, which up here, as you'll see, is just the data range. It's that easy to connect a data range to a chart. You just pass in the range.
Nice. Now, people who are used to using spreadsheet service might have expected that they would actually be getting values for that data range, but here you're actually getting the range, not getting the values, correct?
Right. And that's kind of a cool thing to point out, just because it shows how tightly integrated AppScript is with the rest of the Google Apps ecosystem, right? You just get this range object from the spreadsheet, and bam, you can use it as like a native object here. OK. Now the next step, notice that we're still in the builder. This is another example of a builder pattern. New dashboard panel builder. Set the data table on the builder. Then we bind that builder. So what bind allows us to do is take an array of controls and bind it to an array of charts. So that's what I have here. I have two arrays. One array, these are all the controls: age filter, transport filter, name filter, that we set up here. And down here are the two charts: table chart and pie chart, which we also set up here. Now when you call build, it'll give you the actual dashboard panel that you want to add to your UI app. So next, all we have to do is create the simple UI app, and we will be done. Here we go. OK, let me go through this real quick. Now, as you may be familiar with this, if you're not, there's excellent tutorials on how to use UI app with our various services. You need to create an application, and that application in turn will give you access to UI elements like panels that you can add, widgets that you can add to those panels. And ultimately, you add the panel to the UI app, and then you return the app, and that's what gets rendered in the user's browser.
Perfect. And just a reminder for those who missed sort of the very beginning here, this UI app is looking for the do-get function that we've sort of got our entire chart script here.
Exactly, and I'll scroll up to that. So here's the do-get function. Because this presents a UI, you need the user to see it in, for example, here in a web browser. They'll be able to go to the URL that we generate and then that performs an HTTP GET, which gets this UI, displays it to them. There's also other ways you can embed it in a spreadsheet. We won't go into that here, but suffice it to know, this is how you create it's a very simple UI app.
Yeah. Just a few lines of code.
And what I do is I create a filter panel to contain all my filters, which is a simple vertical panel, and then a chart panel to contain my charts, which is a horizontal panel. And to the filter panel, I add the age filter, transport filter, and name filter, set spacing just to make it look nicer. And charts panel, I add table chart, pie chart, and set spacing. So here's another kind of extension of that pattern we saw earlier. When you call add on this, it returns that panel object. So then you can continue chaining it and calling add again and again to add all the things that you want to it. Okay, and then once you've created your panels containing the filters and charts, you add it to your dashboard, which we created up here.
Yep.
Right here, so I create another vertical panel just to put my panels in. It's just an organization thing. You can do it however you want. There's many different ways to do this, but this is how I do it. So you add these two panels to the dashboard, and then you add the dashboard to the UI app, and then return the application.
It's turtles all the way down.
Yep. So here is everything you need. You open the spreadsheet, get the data range, create the filters, create the charts, add them to a dashboard, return the dashboard. Now, like other publish as a web service applications that AppScript has, the flow is the same. You go to Manage Filters, save a new version, and the version that you want to show to people, obviously. And then you go to Publish, Deploy as a web app, the project version 1, which you just saved. And now I'll just give myself access to see it because this is only a demo. But you would want it to execute as either yourself or the user accessing the app, and then anyone to let other people just get the link and then go to it. Once you deploy it, you get a URL that you can access this app in.
And just to note, if you're using Google Apps for domains, you have the ability on a per domain basis to set what the sharing options for published scripts are.
Yep.
So if you want to create a web app that is visualizing proprietary data for your company, you'll have the option to publish that only to users who are signed in within your domain. So it's live on the internet, but only if you're signed in as a member of your company.
Yep. Right. All right, and there we go. There is our dashboard.
That is remarkably professional for just a few lines of code.
Yeah, and there's still alignment issues here and there. This thing can be aligned to these corners. If I were to spend more time on this, I would definitely do it. And AppScript gives you all the options that you need to arrange this exactly how you want it. You can arrange the padding, the spacing, all of these things, put panels in panels, do whatever you want. And look at our documentation. For that, it very clearly shows exactly what you can do with all of these things.
Let's show some of the filtering options here and show people how it allows us to drill down into the data.
Sure. So here are the 3 filters that we added. This is for the length of commute, which is a number range filter. As you see, it goes between 2 number ranges, and you can drag the sliders. This is the category filter. So these are the categories in the form. They automatically get translated to categories in this drop-down box. And this is the name filter where you can type in strings. Excuse me, this is the string filter. Okay, so let's start out with the string filter, right? On the left is our table chart. On the right is our pie chart. Let's say we want to look at just me. So I'm going to type in my name. Yes.
You spend 100% of your time.
I don't Google myself all the time. What are you talking about? Anyway, so this is me. Instantly, all the charts updated, and the pie chart has just me. That's
a pretty useful pie chart.
So that's my 12% commuting work, and since 12% is all the minutes ever in this data range, all of it. Okay, so let's make it more interesting. Let's look at Dan. Okay, so now obviously you see filters work just like you would expect.
Yeah.
One key thing before even jumping into filters is that just throwing your data in a table chart, for example, is a great way just to get a quick handle of what your data looks like. So here you can arrange it alphabetically by clicking this header. You can arrange it by decreasing age by clicking this. Arrange it by commute times by doing that, etc. Okay, now we can also filter in other interesting ways. Like, let's say we only want to look at the people who are using a carpool. Click that, and bam. Carla, Frank, and Willis are the only ones using carpool, and the pie chart also reflects to see their total minutes commuting, and it looks like Frank has a very bad carpool. Maybe he's the first person pickup, maybe he's a driver, so it takes him the longest. So yeah, and another interesting thing about this filter is, what if you want to look at walking people also? Now you're looking at carpool and walking.
Nice.
So it updates the chart here and adds members in here accordingly.
The nice thing is, if you're using this to sort of do a presentation, in front of a group as well, if you click on one of the segments of the pie chart, it'll actually keep it highlighted with that nice bar there,
nice.
which allows you to sort of use it almost like a laser pointer when you're giving a presentation.
Yeah, just give focused areas to the chart that you want to highlight.
Yeah.
Okay, let's see. And then number range filter is like a dynamic filter where you can do a number range, like you would expect. And as you can see, the pie chart is getting updated as well. It's all very cool. But let's move on to an example that may be more applicable to the real world. Who really cares how long it takes for people to commute to work, right?
You do.
I do. Only me. All right. So let's move on to an example. Lots of people use Stack Overflow. We, as developer relations for AppScript, we're very active on Stack Overflow. We have a tag that you can write your questions against, and we try our best to answer as quickly as possible. So let's say, and we also have a great community of top contributors that also patrol these forums. I'm always amazed to see that I go to answer the question, and then there's already like 3 answers by people that don't work here. It's great. It's great that we have such a user base that's devoted to keeping this project going.
And very well informed, too.
Yeah.
Those guys know their stuff.
Definitely. And so something that I just built simply is that Stack Overflow provides an API to get access to things like the questions posted to it, or the reputation for certain users. There's lots of things that you can query. AppScript's URL fetch makes it easy to get that data. So let's put 2 and 2 together here. We can use URL fetch to get the data. We have a way to present the data with charts and dashboards. Mm-hmm. You glue those 2 together. You have a way to get data, get stuff from Stack Overflow, and automatically have it drive into your charts. Mm-hmm. Okay, in this example, we'll show you exactly how to do that. Let me try to zoom out here. Okay, so, and I'll explain this one in line by line as well, because it's a key to understanding how simply you can do this in AppScript. This is it. This is where here. This is all of the code that you need. What I'm doing here, URL fetch app requires a URL, and then it just gets it. And this is the REST-based API for Stack Overflow. As you can see, there's a couple parameters here. Tags, Google Apps Script, and I'm getting the top answerers, and I'm getting this for all time. So everyone that has answered a question that has been asked against the Google Apps Script tag will be reflected here in some way. Now, once you get the content in this result object, you do JSON parse. The API sends the results in a JSON string. So you do result.get content text and JSON parse, and this outputs a JavaScript object that has key value pairs for what you're interested in. And you can actually see that running here. Let me comment out this logger line. Oh, and before I get to that, I just drill down 1 level into that object and assign it to this variable.
Yes.
Okay. So this is actually the raw output from the API that we were able to get very easily with 1 line. You can get the post count, the score, the name of the user, his reputation, all of this great stuff. And this is for the various users that are identified as top answerers.
But of course, in raw log form, it's pretty hard to read, which is why we're going to get it into a chart here. But it's a really good way to sort of quickly check that you're getting the right stuff from the API.
Yeah, and it's great for debugging purposes too. You build your apps 1 piece at a time, 1 layer at a time. You don't want to just put everything together and have this giant mess where you can't find out where the problem is. So, okay, now that we know we're getting the right data, we can also use the logger to find out general format of the data, right? You can tell that there's objects here, the curly braces denote objects, and you can drill in and you can find the key names of the objects. Like display name is to display the user's name, reputation is that. So that tells you key pieces of information, which I use in the rest of the script that you'll see in just a second. I create a data table here. I'm not using it from the spreadsheet in this example. I'm making it, but I'm making it from the data that I pulled in. And what I do here, I make columns for name, reputation, post count, and score. And these, again, like I mentioned, I got from examining this log. So for every top user that the API returns, for every user, we add a new row to this data table that we set up columns for. And so this add row method takes in 4 parameters according, with respect to the 4 columns that we added. And this is the object that we got directly from the API. So here's top users, user. So we do user, and then we drill down into a user sub-object, and then we get the display name key out of that. Then we do the same for reputation, post count, and score.
Yep.
And then it's that easy to add a new row to your data table. Now what we need to do is build the data table, because as you'll remember, this is the builder. When we add rows to it, we are building the data table still. Then we create the data table, and we create our filters. And I want to filter by name because, again, I want to type in my own name and see my reputation.
I'm seeing a pattern here.
Yeah. But then, OK, so let's see. And we'll display it in a table chart, because like I mentioned earlier, table chart is a really quick way just to visualize things, and then it provides you nice ascending, descending sorts and everything like that. OK, so according to the flow that we established earlier, create a filter, create a chart, and then create a dashboard to hook these things together. And here's my dashboard line here. Charts that new dashboard panel.bind. We're binding the name filter to the chart, and then we set the data table that we built earlier, right here. And now this build call will build the dashboard object.
Nice.
And in the rest of the script, it's just 3 simple lines to create a very simple UI application and add this dashboard panel to it.
Yep, just like last time.
Just like last time. OK, and return the app, and then that's all you need. And now, I was working on this earlier, so you're already going to see a saved version that I was working on, and then deploy web app. I've already deployed it to this URL, so we can just go to that. There you go. So in just a couple of lines of code, you can get this nice table, and you can organize it by reputation. Let's see who's the highest here. Eduardo has 51,046 reputation.
Hopefully, Eduardo is watching GDL right now.
Yeah, and Enrique, he's another guy who's always on top of questions before I get to them. There's very active users in the community. You have to go all the way down here to find someone who's on the team. so here's the number of posts that they posted against this tag, and here's the score for the post. So let's see. Obviously, we're going to use this filter. Check out my name. I actually don't want to do this now. As you'll see, my reputation is not as high as it should be.
Well, I
got to work on that. But
this
anyway.
is going to be our sort of deathmatch leaderboard.
Exactly.
Inside the
this
office
is going to drive us to do better, right? That's the power of just simple dashboards here. You can have the whole team refer to this and be like, hey, I want to get higher than that guy.
Yeah.
Keep on driving up their stats. And we actually do use something like this for our issue tracker as well. Just to make sure that we're all working on it, we're all contributing, and we're all making the user experience the best for our users. All right, and so it's just that simple. In 20, 30 lines of code, you can just get something running. Now, a slight extension to this is the final thing that I'm going to show to you. This is another feature of the Stack Overflow API. Not only can you get the reputation of users, you can also get the questions that they asked against a particular tag. Now, this code is a little bit more complex. It's a little bit more involved, just because you have to do some more processing of the data after you get it. But it's not bad. You can definitely follow along and understand everything. This is not commented because I just wanted to show you without scrolling around too much. But I will comment this code and put it up there, and we'll add a link to it in the event description, so you can access it and look at it at your own leisure. Now, this code is similar in that it contains a do-get. It'll be displayed in a web page just like before.
Yep.
It starts out by calling this getQuestions function, which is something that I wrote. And all this does is it calls another method of the Stack Overflow API here. And it gets everything tagged tag. Sorts by creation, whatever. So tag here is Google Maps. So we're actually fetching all of the questions on Stack Overflow that are tagged Google Maps from this date, which is a Unix epic date. It's basically 7 days before now. I did the calculations, I put it in there. if I made the script more dynamic, I could have the user enter the date and all that. But this is just a sample to show you what can be done. Okay, like before, we get the object by parsing the JSON that we get from the API, and the total field displays the total number of questions. We just keep on doing this while loop until we've fetched all of the questions for the past 7 days. Is basically the meat of this function. It then appends it to an array called questions and returns that to our main function here. In this main function, I want to do a couple of things. The goal of this dashboard is I want to have the date the questions were asked, and we track the total number of questions for that date versus the number of unanswered questions that still remain for that date. This is good for teams like Deverell teams who are patrolling these boards to see, how many questions are slipping through that users are still having problems with, how much more active we need to be. So I set up 3 columns, and you'll see the column type is very important here because the date that's returned is a string, as you'll see in the chart later. But these unanswered and total are numbers, so you can pass them in as numbers, and charts can use them as numbers and filter them as numbers. Ignore this here. This is just to log it. Again, logger.log is a great way to have logging statements and intermediate steps to make sure, hey, I got this far, I'm still on track, I'm still good to go.
And if you want something a little more sophisticated, you can use the built-in debugger in the AppScript editor as well.
Definitely. The debugger lets you step through and examine all of your objects and drill into the objects. And that might be another video coming up, so stay tuned for that. Okay, let's see.
For code as simple as this, really logger.log is all you need.
Exactly. So what I'm essentially doing here is I'm keeping track of 2 objects, total and number unanswered. I'm looping through all of the questions that I get back from my API request and converting the date that's in the questions into a human readable date string without the time, because I don't really care about the time of the question in the day, just the day that the question was asked. And then I create a tally, right? So I added to the num unanswered object if the questions.answer count that I got from the API is 0. And otherwise, I add them to both that and the total. So I have 2 things, number unanswered for each day and the total for each day.
Perfect.
Now I loop through number unanswered. I can loop through either one here. And I create a data table like you've seen before by adding a row for each object. And what I add here is I, which is the key of the number answered, which you can see here is a question date, which is a string. That's a lot of whiches. Anyway, you can add the row, and then it has 2 other things that you pass in to the add row, which is number unanswered I, and then the total I. Obviously, those are the number unanswered and total for each day. Build a data table, create an area chart. Now, area chart is a different chart than what we've been using before. Area chart is good if you want to do things like you want to do stacking. That's a key difference. So here, what my ultimate goal in this dashboard is to have the unanswered at a certain level and then show the total as an addition to the stacking. Okay, so you'll see new area chart, and in the builder, I call the setStack method, which is new for this builder, and then I also pass in the dimensions. Now, just set the axis titles. Like I said before, you can make these charts a lot prettier than what you're seeing right now, so don't think this is all you can do. This is only the tip of the iceberg.
Whatever. My hat is floating beneath the water. I'm like a shark with a hat.
So here we build our table. Okay, so another thing is I want to make an area chart and a table chart. And like I said, table chart is just so that it's like a sanity check. You can see that everything's there that you want it to. So I create both an area chart and a table chart, and I set their data sources to be the same. So they're both driving the same data. Create the application, and you'll notice this time I didn't create a dashboard. I just added the charts directly to the application, which is fine. If you want to simply show something, a dashboard allows you to have controls to drill into it. This time I'm not using controls. I'm just displaying this dynamically queried result. So you can just simply add it. So many ways to do this, and let's go see what it looks like. Like I mentioned before, I was working on this, so I already saved a version. And I already deployed it, so let's copy the web app URL, and we'll try it out. There you go. Looks can be improved, of course, but here is our area chart, and here is our table chart.
That's a really great way of sort of visualizing where we're sitting.
Yeah, so here you see on one axis are the dates for the last 7 days, like I queried from the API, and then on this axis is the number of questions. Red is the total, and this unanswered. You'll notice the stacking method that we called on the builder shows here, where this is 10 questions, and then this is 36, so it's really 36 plus 10. That's why you get up to that's why you get up to 46 here. It stacks on top. So you'll see that the number of unanswered for the Google Maps tag is it could be better. These are the ones that we're covering. These we are not covering.
But they're still keeping it down to a fairly consistent number per day,
it's consistent.
A lot of answered questions there.
And so a key advantage is the same code that you use can be used for other things as well. Now let's go and check out a tag that we all know and love. This changes to Google Apps Script. All right, now I saved it. I need to save a new version because I changed the source. Deploy as a web app, we deploy version 2 here. And now, let's go ahead and see this. And you'll see the numbers here updated because now we're getting different number of questions. For this tag, there are fewer questions asked than for the Google Maps tag. And you also see the distribution is different. The unanswered is lower. Go us. But yeah, your table chart, again, shows easily sortable metrics, and then this will allow multiple people to come into this same central dashboard area and then make sure that we're keeping on track of this thing.
That's great. Just a reminder for anyone who's playing along at home that if you're just building this for your own testing purposes, you can also use the live code link within Deploy as Web App to see what the live version of your changes is without having to redeploy every single time you want to make a change. Right. Deploying the sort of full version is really for when you want to share it with other people in your organization, other people around the world. The dev link, the link that ends in /dev that you'll see in that same...
right here, like this is exact, it could be /dev.
Yeah, exactly. That version will allow you to test your own code really quickly.
Yep.
For demo purposes.
Yep, and that's a great point. So you can avoid that intermediate step of creating a new label and then adding it and all that. Okay, so that's about all I had for charts today. As you can see, it's just a great way to quickly throw up a dashboard, and then just have people go at it, view the data however they want to view it.
That is really cool. One thing I'd like to point people to is I just ran through the charts dashboard tutorial that we have on our site this morning. It's really simple, and the guys who put it together did a nice job of including all of the code right at the end of the tutorial. So you can just paste it into your script editor, manage versions to save a version, deploy as web app, and in 3 steps you have a functional demo charts dashboard. From there, it's a lot easier to sort of walk through, fill it with code a bit, and kind of figure out what each of the parts are doing. Yeah. So if you go to the AppScript website, which is developers.google.com/apps-script, click on tutorials in the sidebar on the left, and then look down the page. You'll find a charts dashboard tutorial. Take a look at that. It'll just take you 5 minutes to get the basic stuff working. And you'll see how powerful the charts dashboard functions are.
There you go. How much easier can it be? All right. Well, you have a lot of choices to continue your education and start building some cool things. So, yeah, go ahead and ask questions on Stack Overflow. Obviously, we're going to stay on top of that, or the issue tracker. And I hope you enjoyed this presentation. Stay tuned for more videos coming up from us.
Yep.
Thank you.
Thanks a lot, guys, and thank you, Kalyan.